Hello and welcome to my video. Today we will take a look at a function that has logarithms in its definition. Well, actually multiple logarithms. So let us take a closer look. The problem says find the minimum value of this function defined on x greater than 1. Okay, how do we do that? First, we can notice that the function contains parts that are identical. So substitution can be a good approach here. And actually, we will make an interesting substitution right here. Here we are going to let log base 2022x plus log base x of 2022 as t. Well, why do we substitute in this way? Well, first, we have a reciprocal relation between log base x of 2022 and log base 2022 of x. So they are related reciprocally. And if you look at the first two terms, we can use the famous a squared plus b squared equals a plus b squared minus 2ab formula. So these two square terms can be written as log base 2022 of x plus log base x of 2022 squared minus 2 log base 2022 of x times log base x of 2022. And since these two terms are reciprocally related, they simply cancel out. And since this part is t, we simply have t squared minus 2 as these first two terms. And this part is simply t. So for that function, we have y equals t squared minus 2 minus 2t plus 1. And this is t squared minus 2t minus 1. And if we complete the square, we simply have y equals t minus 1 squared minus 2. Okay, now here comes the important part, and that is, do not ever jump into the conclusion that y is minimum when t equals 1, because that is possible only if such function can be defined on t equals 1. And that might not be always the case. So it is very important to remind here that whenever you make a substitution, always check the range of the newly introduced variable. So now let us think about the range of t. So t is defined in this way, and the function is defined on x greater than 1. This means that both of these terms are positive. So therefore, we can use the relation between arithmetic mean and geometric mean, aka the AMGM inequality. Here, remember that this holds for only positive a and b. Here we check that both terms are actually positive, so we can apply the inequality to obtain. So this 2 must come out here, and we have square root of log base 2022 of x times log base x of 2022. And like I said before, these two terms cancel out, so we simply have 2. So we have the range of t is equal to or greater than 2. So if we sketch this quadratic function of t, this function has a vertex at t equals 1, but since t is defined in this range, the function is defined only here, so you can see that the minimum value occurs at t equals 2. So it is minimum when t equals 2, and the minimum value of y, we have 2 minus 1 squared minus 2, which is minus 1. So this is the minimum value of the function. And when t equals 2, what is the value of x? Well, t equals 2 means that this equality holds, and from our AMGM inequality, the equality only holds when a equals b. So this equality condition means that log base 2022 of x equals log base x of 2022, which means that x equals 2022. So the function has a minimum value at x equals 2022, and the minimum value is minus 1. Again, be reminded that whenever you make a substitution, you must always think about the possible range of that variable you used for a substitution. And that's all for today's video. Hope you enjoyed it, and I will see you in another video.